This is pre-calculus, notes on section 6.4, trigonometric ratios in the coordinate plane. Trig ratios in the coordinate plane. All right. So first of all, we have to set up that trig ratios can be anywhere on the circle. I want you to make sure that this picture is in your notes.
Make sure you get the picture in your notes.
Thank you. I've got a backseat driver over here. Make sure you get the words in your notes, and then I'm going to move this picture up so you can see the whole thing. So here I've got my angle theta. Okay. Theta has to be in standard position, rotating counterclockwise. So we've got the unit circle, and the place where your terminal side of theta intersects with the unit circle are going to have coordinates x, y, and where x is the adjacent side and y is the opposite side. All right, I'm moving on to the next slide where we're going to expand upon this.
Let's get on to the next slide.
All right, so here we've got the same picture. I made it a little bit smaller so I could fit some more information here. So we already talked about x and y, which are the coordinates of that point where terminal side of theta intersects the unit circle. Now we're adding r. Okay, r is the hypotenuse, and so therefore we can find r by using Pythagorean's theorem.
We need to find RR.
RR. All right. So x is adjacent, y is opposite, and r is the hypotenuse. And then, therefore, these will be our 6 trig ratios. So we've got brand new definitions of the 6 trig ratios, and we're talking about angles in standard position on the coordinate plane. All right, so make sure all of that's in your notes. Here I've got some rules. Make sure all of this is in your notes. When we expand the definition of the trig ratios to any angle in the coordinate plane, the trig ratios can be positive, negative, or 0. When we were talking before about acute angles, right, or right triangle trigonometry that you've already learned in science class, you never had any negative angle measurements, and you certainly never had any angles greater than 90 degrees. They were always acute angles. Well, in our trig class, we're going to talk about angles that can have any measure from negative infinity to positive infinity, and so therefore the trig ratios can have some negative measures as well. All right, second thing. Second thing is that we can measure angles in degrees or radians. I already said the angles can be positive, negative, or 0. Or, however, is always positive, because that is the length of the hypotenuse. In the formula from Pythagorean's theorem, let me go back to here. R is always going to be positive because you're taking the square root of x squared plus y squared. All right, and then finally, coterminal angles all have the same trig ratios. That's important. Make sure all that's in your notes. All right, so here is our first problem. This is a very common type of problem in this section. Okay, we're not given the measure of the angle, but we are given the coordinates of a point that lies on the terminal side of theta. Oh, I just draw that line wrong.
If I did, I did.
Okay. So I'm going to find the point 2, negative 1. Let's make it this point right here. Terminal side of theta. So we've got an angle. We've got a standard an angle in standard position whose terminal side goes through the point 2, -1. So we are going to find the 6 trig ratios. All right. So the sine of theta is equal to y over r. And you're going to have to memorize these too. Okay. Oh, before we do that, we had better find out what r equals. Okay, so let's do r. So r is equal to, or r squared is equal to 2 squared plus -1 squared. Okay. All right, so I've got r squared is 4 plus 1. R squared is 5. Therefore, r is equal to the square root of 5. All right, so now we are doing the sine. Oops, undo that. Now we're doing the sine of theta, okay? Sine of theta is y over r. So y is -1, and r is square root of 5. This has to be rationalized. So multiply top and bottom by square root of 5. So that's equal to -radical 5 over 5, sine of theta. That's my first of my 6 answers. Oh my, stop it, Paterno. All right, now let's do cosine of theta. Cosine of theta. Okay, cosine is x over r, and x is equal to 2.
M equals MC squared. No,
So I've got 2 over the square root of 5. I'm going to rationalize that. So cosine, I don't know why that keeps happening. Not letting me expand the page. Cosine of theta is 2 square root of 5 over 5. I guess since I'm having some technological difficulties here, I am going to just open a new page. All right, so let me copy from the previous page that I already know that x is 2, y is -1, r is square root of 5. Okay, and I've already done sine and I've done cosine, so let's do tangent. Tangent of theta is y over x. Okay, and that's -1 over 2. All right, now cosecant. Remember that cosecant is the reciprocal of sine. And I'm going to go back to the pre-rationalized, let me highlight that, the pre-rationalized version. That's the easiest thing to find the reciprocal of. So the cosecant is the reciprocal of -1 over square root of 5. All right, so cosecant is equal to the square root of 5 over -1, which is equal to negative square root of 5. Okay. Secant is the reciprocal of cosine.
Oh, yeah, what's up? Give me the scissors.
Excuse all of this noise, guys. All right, so I'm going back to the pre-rationalized. Pre-rationalized is this one. We're taking the reciprocal of 2 over the square root of 5. So secant is, oh my god, enough interruptions in this video. You guys are annoying the heck out of me. Not you out there listening to me in my class and here in this moment. All right, so the reciprocal of cosine is square root of 5 over 2. Square root of 5 over 2. And then the reciprocal of tangent, cotangent, is the reciprocal of negative 1 over 2, which is negative 2. All right, that's a 10-minute video. I'm going to cut that off. All right.